in a structure like whirlpool, in something like a whirlpool, in a huge area, all the formed stars must again come through their gravitational attraction towards the center of gravity of the region. Towards the center of gravity of the region. All the stars must be collected like a whirlpool to form a star. Now we have to calculate how long will it take for this gathering of materials or stars to form a galaxy. Normally, to form a galaxy, if the galaxy's radius is r, in a region of a radius of 10 r, the materials in a region of about 10 r must be collected together to form a galaxy with a radius of r. So let's say our Milky Way galaxy has a radius of 50,000 light years. So to form this galaxy, at least the stars of 500,000 light years to be collected together like a whirlpool. Now we are going to calculate that particular time duration, and let's move on for that part. Okay, now we are going to derive the equation, the gravitational contraction equation. And let's assume that there's a system of mass. The center of mass is this, and the center of mass has a collection of all the masses to capital M. And after at a distance of r, there's a small tiny mass called delta M, delta simple M. And now with the gravitational pull of the center of mass, what is happening? This delta M, small mass, is moving towards the center of mass. And now we are going to derive an equation for this process, and we are going to check how long will it take to be combined with the center of mass. Okay. Now according to the gravitational law of gravity of Newton, Isaac Newton, Fg is equal to G capital M delta M delta simple M divided by R square. R is the distance from here to here. The M is the value of the center of mass, the mass of the center of mass. Then delta M is the small mass. Now it's moving towards the center of mass, and the gravitational pull is equal to Fg equals Gm delta M R square. So this is the law of gravity. Okay. Now this is the first equation. Now the second equation can be taken like this. The second equation can be taken like this according to the second law of Newton. F equals ma. So according to the Newton's second law of motion, the acceleration multiplied by the mass is equal to force. In here the force is the gravitational force. Now we can equalize these equations. Fg equals Fg. So from this side, Gm delta M divided by R square will be equal to delta Ma. Now what will happen? The delta M will be cancelled out from both sides. And here it will be Gm divided by R square equal to A. Gm divided by R square equal to A. Now what is V? The velocity. Velocity is equal to At, acceleration divided by the time. Multiplied by the time. So what is V again? The speed is equal to dr divided by dt. Dr divided by dt means the rate at which the r changes with time. The distance change with time. The rate at which the distance change with time is dr divided by dt is equal to at. See, the r is the distance. So dr divided by dt is the speed. Now dr divided by dt is equal to A means this one, Gm divided by R square. Gm divided by R square multiplied by T. Now we can take this section to this part to this side and this part to this side. So R square dr is equal to Gm T dt. R square dr is equal to Gm T dt. Now we have to integrate this equation. Integrate both sides. Integrate R square dr equals to gm integrate t dt. Now from this side it will become r to the power 3 divided by 3 is equal to gm. From this part it will become t square divided by 2. Finally, we can take t to one side and we can take all the other things to other side. We call it make the subject t. Make the subject t. So finally, after taking the subject t, the equation will be t equals to 2r to the power 3 divided by 3 gm to the power the completely to the power half, means the square root. So this is the time duration equation for the time duration for the gravitational contraction, and also this is the equation derived by me as well. And now using this particular equation, now we are going to calculate how long will it take for the formation of a galaxy, and let's move on for the calculation now. Okay, now we are moving on to the calculation, and this particular calculation is for the formation of Milky Way, and this particular calculation is for the formation of Andromeda. And let's start with the equation again. Equation t is equal to 2r to the power 3 divided by 3 gm square root. So here 2 is to r is the range from which the materials or the stars are getting collected to form the galaxy, and 3 is 3, g is the gravitational constant, and m is the collection of mass, the entire number of kilograms of mass which is collected from the gravity, so to form the galaxy. Okay, the radius of Milky Way is 50,000 light years, about 50,000 light years. So we can expect that the material from a range of about 500,000 light years are getting collected to form the Milky Way, and we can take that assumption and we can apply those values into the equation. Now 2 is 2, so the range from which the materials are getting collected or the stars are getting collected is 4.73 to the power multiplied by 10 to the power 20 meters and the power of 3, and divided by 3 is 3, g is the gravitational constant, 6.67 multiplied by 10 to the power minus 11, and the mass, the approximate mass of the Milky Way is 3.96 multiplied by 10 to the power 41 kilograms. So finally, after calculating this one, this from meters, this from kilograms, these are constant, and after calculating this part, we can get the value 1.6340 multiplied by 10 to the power 15 seconds as the time duration for the formation of the Milky Way. And if we take this in years, 51.81 million years will be the answer. And now let's turn on to the calculation about the Andromeda. And Andromeda 2 is to the range from which the materials are getting collected is 9.46 multiplied by 10 to the power 20 kilometers and the power of 3. Divide by 3 is 3, the gravitational constant again 6.67 multiplied by 10 to the power minus 11 and multiplied by the mass of the Andromeda is approximately 7.92 multiplied by 10 to the power 41 kilograms. So this from meters, this from kilograms, these are constant, and finally after calculating this part, you'll get a value of 3.2684859 multiplied by 10 to the power 15 seconds. This is in seconds, and if you convert into years, 104.0311 million years will come as the answer. So finally we can see this. This is the answer for the formation, the time duration that has been taken for the formation of the Milky Way, and this is the time duration that has been taken for the formation of Andromeda, and this is how to calculate the time duration for the formation of a galaxy. And thank you for watching. Let's meet again very soon with a valuable scientific video like this. Thank you very much.